Hi everyone, my name is Nina, and for today's interactive advanced concept presentation number 4, we're going to be conducting an experiment called elephant toothpaste. And so just some background before we get into the actual experiment and what you need. Enthalpy is a thermodynamic quality that's defined as the equation H equals U plus PV. And so the change in enthalpy is a change in H, which is equal to the heat exchange between the system and surroundings at a constant pressure. So for endothermic process, the enthalpy is going to be positive, and for the exothermic process, the enthalpy is going to be negative. Along with that, endothermic process is what's going to actually absorb the heat, which we'll see in this experiment, and exothermic process is what's going to give off the heat. And so with all that background, let's jump on into the materials we're going to need for today's experiment. And what they're going to include is, for one, you're going to want 2 cups, 1 cup of water, and then a pan to kind of catch, hopefully, the explosion that you're gonna create. You're gonna want food coloring. I'm gonna get mine out right now. I'm gonna go for red. You want some dish soap, a cup of hot water, last but not least, some active dry yeast, and then a spoon to kind of help mix everything up. So let's get to it. So you also want hydrogen peroxide, which I misplaced. Here we go, and the hydrogen peroxide. Big component that you need in this experiment. So with that being said, first I have 3%. The higher concentration you're gonna have is gonna perform a bigger explosion, so all to you. This is just what I had laying around, so I'm gonna fill this up less than halfway, since I have only 3%. So got hydrogen peroxide in here. So then what I'm gonna do is I'm gonna add about 3 to 4 drops of my dish soap in here. Oops, 2, 3, 4, 5. All right, that should be good. Got some dish soap in there. And then next I'm gonna take my food coloring, and I'm also just gonna add a couple of drops in there. 1, 2, 3, 4, 5. That's good. I'm gonna mix that up a little bit. Oh yeah. So now I'm gonna put this aside, and I'm gonna grab my hot water and pour my active yeast. Well, I'm gonna activate the yeast. Pouring it in here. Just gonna use all of it. All right, I'm gonna mix that up. All right, I say that has a pretty good mix to it. Just gonna move out of the way a little bit, because now what I'm gonna do, I'm gonna have this solution right here, and I'm gonna pour my active yeast now, and it's pretty warm, and I'm gonna see what happens. Here we go. Sweet. Nice. Exactly what I wanted to happen. So, super cool. So just a couple of things. I'm gonna move this out of the way before it explodes. that was success. That was pretty cool. Like I said, if I probably used a higher percent of peroxide, I would have had an even larger explosion, but I'm happy with what I had. Easy to clean up. So just a couple of whys. So as we saw, we did see a lot of foam. We saw the explosion that probably a lot of us expected to see. And so what's going on? So the concentration of the hydrogen peroxide, even though I had a less amount, it was still pretty effective, in which it was the substitution of the catalyst, and we'll only get more of a reaction with the higher percent, like I said. So let's go into the whys. So yeast acted as the catalyst to the reaction. That was because the yeast contains an enzyme known as catalase. And so catalase is then going to break down that hydrogen peroxide because the yeast contains that enzyme. And so, like I said, the catalase is going to break down the hydrogen peroxide into oxygen and gas and water is what I meant. And so this reaction is and did happen super fast, as we saw. And then the O2 gas is what gets trapped by the soap. And as a result of that is the exothermic process that was produced that we saw. And then lastly, the cup in the experiment was warm and got warm. And then as a result, that's an exothermic process, which is what we saw. So overall, success. Have fun trying this. It was cool.